So valence shell electron pair repulsion theory is showing what the shape of the molecule is because the electrons are trying to stay as far away apart from each other as possible. And the balloons do that quite well because they also want to stay away from each other because they physically are trying to function in their own space. So if you throw up two balloons tied to each other and just let it float around freely, it'll be linear. If you grab three of them, throw them up in the air, they'll actually be planar if you tie them well in the center. And if you tie four together and throw it around, they form a tetrahedral shape or evenly spaced as far away from each other as possible. Drawing the Lewis dot structures is going to be very important because the non-bonding pairs are closer to the nuclei. The bonding pairs are caught between two nuclei and there's more in the middle here. Whereas these guys are closer to the nucleus of nitrogen, and so their repulsion on these bonds is slightly greater, and that will affect the general shape. So the other thing you need to do once you've drawn it is to determine the number of electron domains, because we're going to use the table and we're going to have to memorize the names and angles from the table. And when we use the table, we have to work out how many electron domains there are. And so there's 3 here. And even though there's single, double and triple bonds, they're all in one spot. And so they're still called a domain. And this one here has, around the central atom, has 4. So the general shapes are here. So this is a straight line here. This is a straight line here. This is trigonal planar. We'll learn that as 120 in the table. So we could just use this table if you want, but we don't know how many electron domains are here. Linear is quite a lot of different things. So this one here is typically water. There's 4 electron domains bent. That's 104.5. And the other 0.5 is this one. 109.5 is the tetrahedral. 4 domains all joined up. This one here is trigonal planar. So this one here, it looks kind of similar in that it's a 3, but this one has the 4th domain, so that one pushes that all down. So that one there is 107. Now these two are for high level, so don't worry about that for the time being. So the only one we've missed out on here actually is if that one was just a non-bonding pair. And that one would then be bent, and that's 117. And so as a general rule, as I hope you sort of picked up, it's just a couple of degrees less. So here you've got a tetrahedral, so that's 109.5, and this is then trigonal pyramidal, and it's 107. So you just reduce it by about 2 to 3 degrees, but those actual numbers you need to memorize. This is just a good rule of thumb if you're exposed to something you don't know or you can't remember the number. Reduce it by about 2 or 3 and see if that triggers your brain to get 107. So if you lower this by another 3, this one here is a bent. So lower it by another 3, it's about 104. And this is, hopefully that triggers you to remember it's 104.5. So this is the actual table then. So you need to remember it's a linear 180 shouldn't be too difficult. And trigonal shouldn't be too difficult either because it makes up a 360 degree circle evenly divided into 3. Divided by 3 is 120. So the trickier ones I would say are here, bent 117, the 0.5s as well. And then trigonal pyramidal as well. So I'd say maybe these 4 are ones that you would actually have to spend time memorizing. So tetrahedral 109.5, trigonal pyramidal 107, and bent with the 4 electron domains, but 2 free pairs is the 104.5. Okay, so we're going to use that table and assume you've memorized that now. So spend some time memorizing that, and then we will work out what the shells and shapes and angles of everything is. So the first thing you need to draw is the Lewis dot structure. There may or may not be a central atom. Then you'll work out how many domains there are, because that's going to be important because you need to know how many non-bonding electron pairs are altering the shape. It's the bonded electron pairs that you're going to work on to give the actual shape and angles. So quite a few here. So hydrogen fluoride, when you see 2, that's a little bit of a giveaway. You still need to draw the full electron shell. Excuse me if I'm skipping steps for the electron shells. There's quite a few. I don't know if you want me to do it the slow way. 7. So 7, 1, draw 1 bond. That's now 8. That's 2. They're all good. That must be it. Linear 180. I'm going to actually skip through and try and find some harder ones. And you can stop and do these and see how you go. That's just a simple tetrahedral. I think that's a little too easy. Linear. Okay, maybe this one. Okay, so carbon 1, 2, 3, 4. Carbon 1, 2, 3, 4. Hydrogen. How do you know it's in that shape? That's kind of assuming organic. I'm sorry. That doesn't give you 8. 2, 4, 6. 2, 4, 6. That'll give you an extra one. 7. That'll give you an extra one. 8. So linear 180. When you do organics, you'll know these a lot better. Carbonate, there we go. There's something a little more difficult. 1, 2, 3, 4. Oxygens, 1, 2, 3, 4, 5, 6. I've got to add an extra 2 electrons in there somewhere. I'll give him 1 and give him 1. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I've already put the 2 extra electrons in there. That one's got an extra electron. I'll do the double on that. 2, 4, 6, 8. That's too many. 2, 4, 6. I'll give him the extra electron. The guy that does the bubble bond doesn't get the extra electron. 2, 4, 6, 8. So that's one way of drawing it. Now, because there is we'll learn more about this later. There's resonance, so I could have put the double bond there or there, and that counts as different structures. And so the key point here is there's 3 electron domains. The best thing to do is get the whole class to do and see if they can come up with something different, and then you can analyze it later. So there's 3 electron domains, no lone bond pairs, so they're all even, so it must be trigonal planar and 120. And we got it right. Carbon monoxide, you need to know there's no bonding pairs in the middle, otherwise it's bent. So 1 doesn't work. 2, 4, 6. 2, 4, 6, 7. Do another one. There we go, and it works. So that must be linear. There's no bonding pairs here to make it bent, to make it slightly less than 180. But there is 180, okay? Okay, so the water here, we all know water. All right. Hydronium, if you just throw, so we just did water there, and we throw another one here, it's a H+, join that up with a bond. And so we've got 4 domains, which is tetrahedral. So that's normally 1 in 9.5. We've got a 1 bent there, so that's making it 107 trigonal planar. Trigonal pyramidal. Always accidentally say planar. Trigonal pyramidal. And yep, that's correct. Sulfur dioxide, again, tricky one, because you've got to work out if there's any lone pairs there. So how many is that? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 4, 6, 7. Put a double 1 on there. 2, 4, 6, 8. 2, 4, 6, 8. So that one's right, that one's right. 2, 4, 6, 7. So I can keep 2, 4, 6. Interesting. How do I do this one? 2, 4, 6, 8, correct. 2, 4, 6, 8, correct. Sulfur's period 3. I hope it's not breaking the octet rule. 1, 2, 3, 4, 5, 6, 7. I can't do another bond. It'll break the octet rule. I'll have to do a dative, and I'll have to disrupt that, make that dative. And that's still not okay. 2, 4, 6. This one will be okay then. 2, 4, 6, 8. And then that doesn't work. So I think I'm going to have to break the octet rule here and make this 2 double bonds, 2, 4, 6, 8, 2, 4, 6, 8. No, that actually works now. Just check how many valences. It has 5. 2, 4, 6. 2, 4, 6, 2, 4, 6, 2, 4, 6. There we go. 2, 4, 6. Okay, so that is correct. Now, so that's cool. So now I've got a 3 domains, 1, 2, 3. That's that would have been trigonal planar, but now it's bent. So it would have been trigonal planar 120. So now it is 117. There we go. Got one. Pretty rare. Okay, so bent 117, 3 electron domains. Okay, so that's a cool one, and that's probably why I had so much trouble with it. There are some alternate ones. So take a range check on that, high levels, and you can do like formal charge and all sorts of other stuff on that. But no matter how you draw it, you've got 3 domains, so it's always the same anyway. All right, ammonia, it's got a lone pair here, trigonal pyramidal. So have a go. Try some on the website maybe. You'll get some new ones or your textbook.